YouTube channel. Today we're going to learn about something that is tiny as an ant but changes how you live. Do you know what it is? It's a transistor. Did you know you can find more than billions and billions of transistors in one computer? Then imagine how much it would be used. Now let's see the history of transistors. The first one to patent a field effect transistor was Julius Edgar Lenfield. He did it in 1926. Since he didn't publish any articles about his devices, the industries ignored it. After some time, in 1947, at Bell Labs, John Bardeen and William Shockley and their friends made the first working field effect transistor. Since they made the first working field effect transistor, they got the Nobel Prize in 1956. So what is a transistor? A transistor is a current-controlled current device, or a switch with no moving parts and an amplifier. To learn about transistors, we need to first learn about diodes and semiconductors. So check out my previous video on diodes and semiconductors. So in the previous video, we learned that a P-type semiconductor and an N-type semiconductor combined together forms the diode. And then what happens if you add another P layer or N layer? You form the transistor. There's two variations of transistors. There is a PNP transistor and an NPN transistor. Now let's see the parts of the transistor. There's three parts to the transistor. Let's see the parts. This is the emitter. The emitter emits electrons. This is the base. The base is the one which acts like a switch. This is the collector. The collector collects the electrons the emitter emits. To visualize this more clearly, I've got this tiny shared sheet. So as you see, this part where it contains the water, which is representing the electrons, is the emitter. This part where the water comes out is the collector, and this part is the base. So when I apply tiny current through the base, the electrons from the emitter flows to the collector. Now let's see the different types of transistors. There is bipolar junction transistors, and the two variations of a bipolar junction transistor is a PNP transistor and an NPN transistor. There's also another kind of transistor called a field effect transistor. The variations of a field effect transistor are MOSFET transistors and JFET transistors. Now let's see the working principles of a transistor. To make a transistor work, we need two voltage sources. The primary voltage source, the secondary voltage source. The primary voltage source is the one the load utilizes. The secondary voltage source is the one that controls the transistor. Let's take this NPN transistor as an example. So in order to make this transistor work, we need to forward bias the emitter base region. To do this, we need to connect the positive side of the secondary source to the base, the negative side of the secondary source to the emitter. When we do this, the electrons from the emitter move to the base, and some will go through here, but the majority of them will come out of the collector and then to the load. This is how a transistor works as an closed circuit. Now let's see how it works as an open circuit. To make it an open circuit, we need to reverse the battery connection. When we do this, the transistor starts behaving like an open circuit. Now let's see how a transistor is used as an amplifier. So the electrons from the secondary source and the primary source adds up, and then more electrons go through the collector. Since the electrons add up, it amplifies. So now let's see the uses of the transistor. The transistor can be used as an amplifier and a switch. Now we'll learn how to make a pretty fun project at your house. To make this project, you need a breadboard, a 50 kilo ohms resistor, a 100 ohms resistor, and an LDR, and some male-to-male wires, and a BC547 NPN transistor. So this is how the circuit diagram looks like. And so now let's see how this circuit works. So if there is light at the photodiode, when there's light near the photodiode, the resistance of this photodiode is low. So the electrons will try to take the photodiode path. But since it's connected to the negative side of the battery, the whole transistor will be reverse biased, so it will behave as an open circuit. But when there is no light, the photodiode resistance will increase, and the electrons will take the 50 kilo ohms resistor path, and then will forward bias the whole transistor, so then the light will start to glow. This is how this circuit works. And now this is like I've got the circuit, and as we see here, when I put my hand near the photodiode, the light starts to glow. This is how the circuit works. Hope you liked the video. For more questions, please comment and share this video. And if you haven't subscribed, please subscribe. நன்றி, வணக்கம்.